Hi, Assalamualaikum everyone. We are from Group 5S19. In this video, we will be presenting about our math assignment. Before we proceed, my name is Umar Asfar bin Azli.
My name is Muhammad Adam Haikal bin Mawaris.
My name is Nur Akila Amani binti Muhammad Asman.
And my name is Nura Afrina binti Ahmad Zulkaha.
So, let's get started.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. We'll be presenting about the growth of population in South Korea. Okay, for the objective is to find the particular solutions of the differential equations for the growth in the population of Korea from 2000 until 2019. Second, to predict the future value of the human population of Korea in the year of 2021. And lastly, to predict the past value of the human population of Korea in the year of 1999. And lastly, to predict the past in this presentation, we already find the data for 20 years, starting from year 2000 is around 47 million and 8,111, while in 2019, the population is around 51,764,822. And we also have to calculate the past value and future value, impacts of the population growth in Korea, and factors that affect the past and future value. So these are the tables for the data of the number of population from year 2000 until 2009. And the other slide is from 2010 and 2019.
As we can see here, this is the graph from dataset and the particular solution. We can see the blue dotted line, which is stand for the from dataset that we have been collected in the population of growth in Korea, while the red line is stand for the particular solution that we have been calculated from the equation. Okay, first and foremost, we need to let PT is the number of population in Korea at time T year. And since the rate of growth is proportional to the number of population in Korea, PT, then dP over dt is equals to Kp, where K is the constant of the proportionality, T, which is 1 over P dP is equals to K dt. Then we need to integrate both sides of the equation. We will get ln P equals to Kt plus C. So we will get the modulus of P is equals to e the power of Kt multiplied with e the power of C. So since we need to remove the modulus, we will get the final answer is the P is equals to plus minus e the power of C is multiplied with e the power of Kt. The general solution can be simplified to be P is equals to a e the power of Kt, where plus minus e the power of C is equals to a. By using the initial condition, T is equal to 0, which is 2000 year. So the P we will get 47008111. So we will get the final answer is A is equals to 47008111. Then the general solution becomes P is equals to 47008111 e the power of Kt. We also can find the value of the constant K by using T is equal to 17 in year 2017, which is P is equal to 51361911, and we need to substitute into the equation. We also need to determine the number of female population in year 1999, which is T is equals to -1. So when we substitute the equation, we will get the approximately 467,63835 population. While we also need to determine the number of female population in year 2020, which is T is equals to 20. When we substitute the number, we will get the approximately around 52170654 population. After we have been calculated all the data from the equation, we need to find the percentage of error from both past and the future. For past, we will get 0.3157%, while the percentage of error of future, we will get 0.6451%. Okay, what is the difference between the actual value and the value calculated from the particular solution? First and foremost, this is because the K, which is growth rate, is an estimate. The value calculated from earlier data might not constant over time. Second, it might be from the rounding and calculator approximation. Small changes of approximation can affect the final answer slightly. And last but not least, it might be from the model is ideal and not realistic. As we know, the population growth might be affected from disease, economy, and more.
So, what has affected the population growth in the past? First, women's education and employment. This is because more women pursued higher education and entered the workforce, which often delayed marriage and children. Second, the government policies, which is South Korea has strong anti-natalist policies to control rapid population growth. And lastly, is marriage trends. This is because people started marrying later or choosing not to marry at all. This contributes to lower birth. So, what has affected the population growth in the past? First, women's education and employment. This is because why population growth in South Korea is decreasing? First, it is because very low birth rate. South Korea has the lowest fertility rate in the world. That means Fewer babies are being born than people dying, so population shrinks over time. Secondly, urbanization. Most people live in big cities like Seoul. In urban life, having kids become expensive and less practical. Small apartments, daycare competition, lack of family support system, it all adds up. Third, it's about aging population. The population is aging fast, more older people, but fewer young people. That creates a demographic trap, fewer working age people to support retirees. Lastly, low immigration. South Korea has historically had low immigration levels, unlike places like the US or Canada, which offset low birth rates with newcomers.
Now, let's move on to the task 2. As you can see over here, there is a formula of Simpson's rule. If we simplify this equation, we got h over 3 times y0 plus yn plus the coefficient of 4 times sum up of y odd number plus coefficients of 2 times sum up of y even number, where with h is equals to a minus b, which is its limit, over n, which is its subinterval. Now, let's take a look at the questions. The question asks us to estimate the area bounded by curve y equals to 2 times cube root 4x cubed minus x minus 2 over x plus 1, the x-axis, x equals to 1 and x equals to 5 using Simpson's rule with 4 and 8 subintervals. Leave the final answer correct to 6 significant figures, where with h is equals to a minus b over n. Now, let's move on to the task 2. As you can see over here, there is a formula of Simpson's rule. If we simplify this equation, we got h over 3 times y0 plus yn. So here's the data that we obtained by using Microsoft Excel. As you guys can see over here, we are already list down all the value of fx. To find the value of fx, we just simply use the equation given from the question previously. Since from the question asks us to use 4 subintervals, so the value of n just from 0 to 4. Next, to find its width, we got 1, since a and b stands for limit and n stands for subintervals. So the value of x that need to substitute into the function is start from 1 and followed by the next value, which is 1 plus h, which is 1. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and finally 4 plus 1 is 5. And then for percentage error, we compare between the actual value and expected value. Thus, we got 0.607956092. So here's the data that we obtained by using Microsoft Excel. As you guys can see over here, we are already list down all the value of fx. To find the value of fx, we just simply use the equation given from the question previously. Since from the question asks us to use 4 subintervals, so the value of n just from 0 to 4. Next, to find its width, we got 1, since a and b stands for limit and n stands for subintervals. So next, if we calculate manually by using the formula of Simpson's rule, we also got the same value as the Microsoft Excel give. So here's the graph for 4 subintervals for this function.
For my turn, I will be explaining for 8 subintervals. For 8 subintervals, we also need to calculate the width, which is b minus a divided by n, and we got delta x, which is 1 over 2 or 0.5. In column A, we list down all the subintervals, which is n, from 1 to 4. For column B, we list down all the sequence of width for subintervals, which is x, starting from 1 to 5. And for column C, we label as fx, calculated by using the equation that from question. For column D, we actually list down all the coefficient that we got from the Simpson's rule. We actually list down all the coefficient that we got starting from 1, 4, 2, 4, 2, 4, 2, 4, 1. And for column C, it's actually the value that we multiply the coefficient and fx, and we sum up the value. We got 53.24974,531. To calculate area under the graph, we use equation 1 over 2 divided by 3 multiply with starting from 1, 4, 2, 4, 2, 4, 2, 4, 1. And for column C, it's actually the value that we multiply the coefficient and fx, and with total value, and we got 8.874957552. The actual area value that we got from Desmos is actually 8.86281.909. For percentage error, we compare between actual value and the expected value. Thus, we got 0.127598998%. This shown that 8 subintervals is more precise than 4 subintervals. This means higher subintervals means higher accuracy of the area value. If we calculate manually, we will get the same answer as in Microsoft Excel. So this is the graph for 8 subintervals for this question.
That's all from us. Thank you.
Bye.
That's all